So let's see the first point here. What they say is acceleration is the rate of change in velocity per unit of time measured in meter per second or meter per second square. Okay, so rate of change of velocity, you see this is the important words. We look at the formula at the same time. V minus U over T. Okay, so when you look at the formula together with the definition, it should be easier to understand, where change in velocity is V minus U. V minus U is the change in velocity, where V is the final velocity, U is the initial velocity. So that is the change in velocity. When I have rate here, that means how fast the change in velocity happened. So that's why we divide by time to find out the rate. So change in velocity over time. Okay, so the unit should be kind of reasonable also. You know, change in velocity is meter per second, then you divide by time again. So that's why we have a second square there. Okay, so acceleration is a vector quantity. So that means direction is there. Direction is there. So I give you an example. Let's say direction is important. Okay, example. Okay, so if you have a trolley or a car with U equal to 5 meter per second, move forward, and then at the end it become, let's say, 8 meter per second, and let's say this happened in a time of 5 seconds. Okay, so 5 seconds. So if you want to find the acceleration, right, so you can see A equal to 8 minus 5 over 5. Okay, let's say I use different value. Okay, I use different value so that the values is not that confusing. Okay, let's say I use 2 seconds. 2. 8 minus 5 is 3. 3 over 2. 1.5 ms negative 2. So that means it takes 2 seconds to increase 3 meter per second. Okay, so you can see here 1 second it increased 1.5, so 2 seconds it increased 3. Okay, so 5 to 8 is increase of 3. So this is acceleration. Okay, so it is moving forward and accelerate. So this is the first example, moving forward and accelerate. So end up with a positive answer. Okay, now I give you another example. Okay, so the second example, now let's say I put a trolley again, U equal to 5 meter per second, slow down to V equal to 3 meter per second, and let's say this happened in 2 seconds or so. So we count A. So V is the direction of motion is to the right. So V is 3, U is 5, time is 2. So negative 2 over 2 is negative 1. Okay, so you can see something like this, we get a negative value. So you should know that negative means decelerate. But I have to let you know more. It is moving forward and decelerate. Moving forward and decelerate. Okay, so you get a negative value. Okay, now let's say one more example. Okay, so this time I'm going to make it move backwards. So the trolley is moving backwards. U is, let's say, 5 meter per second. and it's moving backwards but it's getting faster, v equal to 8 meter per second. Okay, so the thing is, when they are moving backward, we normally assume backward as negative. Okay, so the u should be -5, the v should be -8. Okay, because backward is assumed to be negative. So if I use the formula, and let's say this happened in 2 seconds again, 2 seconds, t equal to 2. Okay, so I use the formula a equal to v minus u over time. Okay, then you will get -3 over 2, -1.5 meter per second per second. So what you see here is negative doesn't really mean decelerate. You see, you get negative here, but it is not decelerate. It is accelerating. It's getting faster and faster. From -5 to -8, it's getting faster. Okay, so what we can say here is it is moving backward, and accelerate. We end up with a negative answer. Okay, we end up with a negative answer. Okay, now last example. The trolley is moving backward again. U equal to -5 meter per second. And at the end, moving backward, V equal to slow down, -3 meter per second. Still moving backwards. And let's say this happened in 2 seconds. T equal to 2. So if I go and count the acceleration, right, V minus U over time, so you get 2 over 2, which is 1 meter per second square. Okay, so you get a positive value. It doesn't mean positive is accelerating. If you look at our situation here, obviously this is slowing down from 5 to 3. It is slowing down. Okay, so this is moving backward and decelerate. End up with a positive answer. Okay, so 4 situations to cover up all scenarios. So the conclusion is, how we know it is positive or negative? There is a technique. So the technique is, if they are moving forward, positive. Accelerate, positive. Positive times positive, you end up with positive. Moving forward, positive. Decelerate, negative. Positive times negative, end up with negative. So that's why you can see positive. This is positive answer. So this is negative answer. Okay, now you see again, moving backward is negative, accelerate is positive, so negative times positive end up with negative. So that's why you get a negative answer. And finally, moving backward, negative, decelerate is negative, negative multiply with negative end up with positive. So that's why you see here, you get a positive answer. Okay, so 4 situations. Okay, so we already understand acceleration. Positive acceleration means the velocity of a body is increasing. So remember, this is for this scenario. Moving forward and accelerate, and then your acceleration is positive. So positive acceleration means the velocity of a body is increasing. It's referred to our first situation. Okay, now let's see. Next point. Deceleration or negative acceleration means the velocity of a body is decreasing. Okay, so it refers to this situation. If the object moving forward but it is slowing down, So you should get negative acceleration or deceleration. So must be moving forward. This two statement is true for moving forward. But if they are moving backward, so you just refer to the two situations that I gave. Okay, now let's move on. If acceleration is not constant, the speed or time graph will be curved. Speed versus time graph. Okay, something like this. Speed, time is a graph. It's a curve like that. So if it's a curve, that means the acceleration is not a constant. So of course the concept behind it is, I hope you still remember, the gradient is the acceleration. You see the gradient is changing from less steep to steeper. So the gradient that represents acceleration is hence changing also, increasing also. So acceleration is not constant. The downward acceleration of an object is caused by gravity. So for example, you release an object from a certain height, it goes down because of gravity. This happens most when an object is in free. Is in free means you release your hand, the objects fall down. That is in free. Objects are slowed down by air resistance. So imagine something like this. You release your hand, the object go down. So going down is because of gravity. So gravity causes weight. Acting downward is weight. Okay? Gravity causes weight. There is an air resistance that push the object up. Air resistance. It's like when you want to go down, then the air is blowing upwards. I think you should experience before. Okay, that will slow down the motion. Air resistance. Once air resistance is equal to the force of gravity, the object has reached terminal velocity. So how is this happens? Okay, I give you one example. Okay, so let's say you stand on a cliff. Okay, so you are holding a particular object. Okay, let's say this is your hand, you are holding a particular object. You release the object, so the object will fall down. This is the object. You release, then it falls down. So at the beginning, because the object has it's not moving that fast, or maybe it starts from stationary, So at the beginning, the weight is there, but the air resistance is zero. Air resistance is zero. Air resistance, I use short form. AR is equal to zero. Basically, air resistance is affected by the velocity because the object is stationary at the beginning. So no velocity, no air resistance. So the weight is acting on it. The air resistance is not acting. So because of that, the object is accelerating. Object accelerates. Okay, so it accelerates. That means it's getting faster. So the object is accelerating. Okay, so object accelerate. It's getting faster and faster. So when it accelerates, velocity increase. Velocity increase. Air resistance, AR increase. The object is accelerate, it's getting faster and faster. Air resistance increase. So imagine if the object is here now. Acting downward is the weight. Acting upward is air resistance. the air resistance is getting greater and greater until at a point where the weight and the air resistance are equal in values. Okay, so when weight equal to air resistance, there is no resultant force. When there is no resultant force, there is no more acceleration. In that case, the object moves at constant velocity, and we call this constant velocity as terminal velocity. So that's why there is a term terminal velocity written there. So, yes.
I'm a bit confused with this. Can you repeat again, please?
Okay. Yeah. Okay, you see it again. It is a whole story of sequence or events that happens. Okay. Now you see, at the beginning, you are holding the object. The object is stationary. Okay. You release your hand, the object starts to fall down. Okay, so at the point when you just release your hand, what force is acting on the object? So first, the weight, the gravity. Gravity causes the weight. Weight is acting on the object. How about air resistance? Air resistance is 0 because the object is stationary. So there is no air resistance, only weight. And because of that, the weight makes the object accelerate. Which means the object is moving faster and faster. So when the object is moving faster and faster, its velocity increases. Velocity causes the air resistance to increase. The faster the object, the greater the air resistance. So it comes to a point where the air resistance is equal to the weight. When the object is fast enough, right? So there is a point where the weight is equal to the air resistance. So when weight equal to air resistance, weight is acting downward, air resistance is acting down upwards. So they are balanced. They are balanced off. At that point, there is no resultant force. So when there is no resultant force, we have a formula here, Newton's second law. Of course, you will learn Newton's second law later. Now you just take it like this first. When there is no resultant force, there is no acceleration. So object move at constant velocity because no more acceleration. And we call this velocity as terminal velocity. Okay.
Okay, so can I know what is resultant force?
Resultant force is the net force. It's the net force after considering the weight and the air resistance. What force that remains is the net force or the resultant force. Yeah.
So is it like the resultant force is the weight equals to the air resistance?
Resultant force over here is actually weight minus air resistance. So that is the resultant force. Basically, it's something like this.
Total force that's left.
Yes. Yeah, that's the resultant force. Okay. Now, let's come back to the point in the notes again. It's a very complicated process, right? But you try to slowly get used to it. So if you still can't get it, just repeat the video again. You listen to it again. At the end, you will get used to the idea of all this. Okay. Now you see the words again. Yeah. Okay, we start again. The downward acceleration of an object is caused by gravity. Okay, so gravity causes weight. Weight causes downward acceleration. This happens most when an object is in free. We call it free fall. Free fall. That means you release the object, you let it fall freely. Objects are slowed down by air resistance. Okay, so air resistance is acting upwards, so that's why it makes the acceleration to decrease. Actually, acceleration decrease. Once air resistance is equal to the force of gravity, there is a point where the air resistance is equal to the weight. When the object is fast enough, we come to this point, and at that point the object has reached the terminal velocity. So at that point, when the weight equal to the acceleration, no more resultant force, no more acceleration, then it will come to terminal velocity. So this is the short version. This means that it will stay at a constant velocity. Terminal velocity means constant velocity. Acceleration of free fall for a body near to the earth is constant. Okay, where g is 10 meter per second square. Per second square, there's supposed to be a square there. Even just now, meter per second square is left out also. So here, left out the square here also. Okay. So this g equal to 10 meter per second. How to use? So for example, you want to count the weight. You use weight equal to mass time gravitational acceleration. So we use that. You see, W equal to mg. Let's say the object is 2 kg. And then you take 2 times 10 to get the weight. The weight is 20 Newton. Something like this. Okay. So example, if the object is 2 kg. Okay. Now, mass and weight. Okay, we start from mass. Amount of matter an object contains and is a property that resists change in motion. Okay, so as you can see here, they are trying to explain the meaning of mass. Okay, so 2 points they are talking about. The first point is amount of matter an object contains. What is that? So for example, if you have solid, basically it has more matter inside it, because solid is like this, right? So it has more matter. So the amount of matter here is the mass. Okay, so represented by kg, like solid, basically you should expect more matter, then heavier. Okay, the mass is higher. Liquid, you see, like further apart compared to solid. Gas, far away from each other, so you should expect less matter. This one more matter, this one having the greatest number of matter. So that is the mass. Okay, that's the first point, amount of matter. The second point is a property that resists change in motion. So how it works, let's say one example, resist change in motion. Okay, so there are 2 ideas. Resist change in motion. First idea, object which is stationary is hard to make it starts moving. For example, a big elephant. It's so huge, so heavy. You want to make it start moving, you push it. It seems like it is very hard to make it start moving because it's very heavy. So elephant with a big or a great mass is hard to start moving. So that is resist change in motion. Okay, now another example. Object which is moving is hard to stop. Okay, that is also another situation. So imagine the elephant is running because the elephant saw a rat. Okay, so when the elephant is running, you want to make it stop. You use your hand to hold the elephant. I don't think it works. It is very hard to make it stop. So that is the mass which affect the change in motion. Okay, so from here you have to get the idea. The idea is, if the object with high mass it is hard to make it start moving, and moving object is hard to stop. So this is the concept behind mass. Okay, so remember that. Let's use elephant as an example. You should be able to take it. Okay, now let's look at the next point. Weight is the force of gravity acting on an object. Okay, so just now I mentioned gravity causes weight. So because of the presence of gravity, there is weight, and they are related in this way. Weight equal to mass times gravity. So weights and hence masses may be compared using a balance. So that means you can use balance to check the weight. What kind of balance? Spring balance. Have you heard before? Spring balance?
Yeah.
Spring balance is to check the weight.
Yes.
And you want to check the mass, you can use other kind of balance like beam balance. Have you heard before? Beam balance?
Yeah.
Okay, so there are different kind of balance to check the weight as well as the mass. Okay, so we have done this part. And okay, so this is question that is related to what we discussed just now. So let's take a look. Question 2. A boy steps off a high board into a swimming pool. So it's like free fall. Figure 2.1 shows the forces acting on the boy at one point in his fall. So the force 540 Newton, that is the weight. So I label first. This is the weight. The 100 Newton that acts upwards is actually the air resistance. Okay, the air resistance. Okay, now part A. The 540 Newton force is caused by gravitational attraction. Okay, and then state the cause of the 100 Newton force. So it's caused by
Air resistance.
air resistance. Yes, correct. Air resistance. Calculate the mass of the boy. So we have to use the formula. Weight
Equals to mg.
equal to mg. Yeah. So writing down the formula, you will get 1 mark. And then you substitute values. 540 m. The g is 10. Then you get the m. 54 kg. And then you write 54 here. So the answer 54 will give you the second marks. The second marks, 54. Okay, now part C. Calculate the resultant force on the boy. State its direction. Okay, so resultant force, just now we discussed. Resultant force is actually weight minus air resistance. So the weight is 540. The air resistance is 100. So you end up with 440 Newton. Okay, so the answer, resultant force 440 Newton. So directions downward, because the man is going down, so that's why downward. Downward. Okay, so from these questions, you will realize what you heard just now is very applicable in this question.